Today we're going to be doing sections 12.3 and 12.5. We'll be talking about pyramids and cones, and once again, the lateral area, surface area, and volume of those figures. So first we're going to talk about pyramids. Pyramids are different than prisms in that instead of having two congruent polygon bases, there's only one polygon base. And then the triangular faces, the lateral faces are now triangles instead of rectangles, all meet at a point called a vertex at the top. So pyramids have two different kinds of height. A right regular pyramid has a height of the pyramid, which we'll label with H, that goes from that top vertex to the center of the base. That's the height of the pyramid. And then we have the slant height, which is the height of those triangle faces, or those lateral faces. We also have lateral edges where the triangles meet. And notice that those are not the same as the height of the triangles or the height of the pyramid. So there are three measurements that you're going to need to know inside of pyramids. The lateral edge, or the place where the triangular faces meet, the altitude, or the height of the pyramid, which goes from the vertex to the center of the base, and the slant height, which is the height of the triangular faces. When you have oblique or non-regular pyramids, the slant height is not the same for all of those triangles. So there's not one slant height for your pyramid. When we come up with formulas, we will be working with only regular pyramids, which have a regular polygon for their base, so that all the triangle faces, or the lateral faces, are congruent and isosceles triangles. You will be classifying your pyramids like prisms. Pyramids are classified by their base. These are all regular bases, and therefore the triangular faces are all congruent isosceles triangles. Then you will draw a net for each of those. Use your web link as a guide. If you scroll down, once again, we have different types of pyramids that you can see in their three-dimensional form and rotate around, and that fold out to make the net. Finally, once you've done that, go ahead and come up with a formula for pyramids for the lateral area and then surface area. Lateral area needs to be in terms of the slant height and the perimeter. Again, we're talking about the perimeter of the base. Use what you learned from the lateral area and surface area of prism as a guide to help you in this activity. Okay, now that you've figured out those formulas for lateral area and surface area of a pyramid, and you know that you have to use the slant height and the perimeter to get those, I want to go over some very important right triangles in pyramids that you'll be using to solve for some of those missing parts of your formulas. The first right triangle is inside the pyramid. This side over here is the height of the pyramid, or the length of that segment that goes from the vertex to the center of the base. This part here is the apothem of your triangle, the segment on the base that goes from the center and is perpendicular to the base edge. And finally, this side here is the slant height. This triangle is found inside the pyramid. The second right triangle is on a lateral face itself. It's a triangle on that isosceles triangle lateral face. This now leg is the slant height, the point going from that top vertex perpendicular to the base edge. Because it's an isosceles triangle, that segment also cuts the base edge in half. So this length is half the length of the base edge. Finally, we have the lateral edge, the place where two lateral faces meet. Our third right triangle is found on the base, and we used this in Chapter 11 when we found the areas of regular polygons. That has the apothem, half the base edge, and the radius of that regular polygon as the hypotenuse. These are very important right triangles that you will be using whenever you calculate the lateral area or surface area or volume of a pyramid. Cones, again, are a lot like pyramids in that they have a slant height and a height, a radius, and that there are right cones and oblique cones. They're different in that they don't have lateral faces, but have one lateral area, and their base is not a polygon, but a circle.